Alright everyone, and welcome back to the AI Research Roundup. I'm your host Alex, and today is May 4th, 2025. We're diving into this ICLR conference paper published a few months ago, back on January 22nd, titled Limits to Scalable Evaluation at the Frontier, LLM as Judge Won't Beat Twice the Data. This paper investigates using LLMs as judges for evaluating other models, finding that biases really limit how much they can replace costly human annotation, particularly for the newest, best models. Okay, so diving right in, this first figure really highlights the core issue. On the left, we see a semi-synthetic setup with GPT-4 as the judge, and on the right, Llama 3 to 70B judging real models. Look how the rankings get shuffled. Even with decent accuracy, like 84% for GPT-4, the order of models changes quite a bit compared to the true labels. This shows how LLM judge biases can really mess with the results. Okay, so how much data can we actually save by using these LLM judges and debiasing methods? Well, this next chart shows the maximum theoretical sample efficiency factor using different judges like GPT-4, Claude Sonnet, and Llama 3 to 70B. Evaluating various models on MMLU, notice how most bars stay below that dashed line at 2? This means you typically can't reduce the needed ground truth data by more than half, unless a strong judge evaluates a much weaker model. Building on that, this figure shows concrete results using GPT-4 as the judge on the MT-Bench benchmark. Okay, so we see it evaluating models like Claude V1, GPT 3.5 Turbo, Vicuña, and others. Notice again how the sample efficiency, that's the y-axis, mostly bumps up against that dashed line at 2, but rarely crosses it significantly, especially considering the error bars. This really drives home that factor 2 practical limit for data savings. Okay, and this next figure shifts to using Llama 3.1 to 405B as the judge, this time on MMLU. It compares sample efficiency using binary scores, shown in blue, versus non-binary scores in orange. Well, the non-binary scores do help a bit, pushing efficiency up slightly. But look, for most competitive models like Claude, GPT-4, and Gemini, we're still bumping against that factor 2 limit. Only when judging the much weaker Llama 2 to 7B do we see a bigger gain. So, moving on, this next figure gives us a broader look at the best possible sample efficiency, tau_max. Okay, we see results using different judges like GPT-4, Claude Sonnet, and Llama 3 to 70B, evaluating various models along the bottom. Look at the X marker showing the actual tau_max. They mostly hover near or below 2, right? Only when judging the much weaker Llama 2 to 7B do we see a significant jump. This really reinforces that factor 2 limit we've discussed. Okay, now this figure is quite interesting. It shows model rankings on MMLU again, but this time using a hypothetical judge that's only 60% accurate. Crucially though, its errors are random, not biased like an LLM's might be. Look, on the left and right plots, the rankings are mostly preserved despite the low accuracy. This really highlights that it's the bias from LLM judges, not just inaccuracy, that distorts rankings and limits efficiency. Alright, so that comparison really underscores that it's the bias in LLM judges, more than simple inaccuracy, that messes up the rankings and limits efficiency. So, the big picture here is, LLM judges with debiasing are helpful, but not transformative. They can roughly halve the amount of human annotation needed, but they won't replace it entirely, especially when evaluating the very best models. Okay, that's all for this week's AI Research Roundup. Thanks for joining.